Alright, what's up guys? So in this video tutorial, I'll just be going through an example to demonstrate how we can use NPV, so net present value, and benefit cost ratio in order to analyze a certain project. So in this example, what we have is we've got a project with several cash flows. You can see initially we've got $10,000, and it's associated with a negative sign. And that means that it is a cost that we have to pay out of our own pocket, so it's an initial cost. We also have these $2,000, and they go from year 3 up until year 6. So, and because they're associated with a positive sign, this tells us that it's a benefit that we're getting. So it's an annual benefit. We also have this cost, an annual cost of 1,000 from year 4 until year 6. And then finally we've got the salvage value, so the value that we get at the end of the project once we sell it, and that's positive because that's money that we get into our pocket. And we need to analyze this project, whether it's feasible or not, using NPV, net present value, and using benefit cost ratio. So what are the first steps that you have to do? The thing that you have to remember is that you have to construct a timeline, just like you can see over here. And in that timeline, just so that you avoid confusion, always associate a positive sign with any benefit that you have. And then associate a negative sign with any cost that you have. And this just makes your life easier. So once you do that, and once you construct your timeline, just like you can see over here, next step would be to start the calculation process. So the easiest way to do that is to actually break it down into steps, just like I'm going to do now. So step 1, let's have a look at the annual costs. So if we have a look at our annual costs, given that it's an annuity, we need to use the annuity equation. And the annuity equation is P, so the present value is equal to the annual payments that you receive each year, 1 plus I, which is your interest rate, to the power of n minus 1, divided by I, 1 plus I to the power of n, close the big bracket. And in our example, I is taken as 5%. So your interest rate is 5%. So the annual cost that we're looking at is the 2,000 is the minus 1,000. So it's the cost that's associated with the negative sign. So it's the $1,000 over here. And notice that it starts at year 4. Now the thing with this equation is that it takes you back 1 period less. So it gives you the present value 1 period less, 1 period less than the amount, than the period where the first amount started. So the first amount over here started at year 4. And using this equation, using the annuity equation, it's gonna, if I were to plug in the values, I'm gonna get the present value at 1 period less than period 4. 1 period less is at period 3. So there's going to be 2 steps that I have to do. Number 1 is get the present value at year period 3 from the equation, from the annuity equation, and then the next step. So the second step would be to actually discount this value back to present value year 0. So present value year 0 is where I actually want to conduct my analysis. So let's do that. So first off, with this equation, just plug in the numbers. And I get P year 3. So my present value at year 3, remember, because my payment started at year 4, and this equation takes me back 1 period less, which is period 3. So present value at year 3 is equal to 1,000. Now don't associate any negative signs in these calculations. So the negative signs, we're only going to use them for the timeline, and we will use them at the end, as you will see. So 1,000, 1 plus 0.05, so the 5%. Yeah, n is 3, take away 1, and then 0.05 multiplied by 1 plus 0.05 to the power of 3, close the big bracket. And if you were to plug that in the calculator, what you should get is $2,723, rounded up to the nearest dollar. So 2,723. Okay, so as I said, we still need to discount. So 2723 is the amount that I get at this period. So that's 2723. I still need to take that back to period zero. Before I do that, I just want you to note that this 3, how did I get the 3? Well, what you have to do is if you go back to your timeline, how many payments do I have? I've got 1, 2, 3, and that's where I got my 3 from. So 3 payments, that's why we've got 3, so that's why n is 3. Now in the second step, as we previously said, we need to discount this value. So this amount, we need to discount it back to period 0. So step 2, discount previous figure back to year 0. And to do that, I need to use this equation. So b f 1 plus I to the power of n, where f is your future value, p present value, I interest rate, and n is the number of years. So in our case, p is going to be at 0. The future value is what we had before, 2723. So I got that from the step above, and then 1 plus 0.05, and then n. How do we calculate n in this case? So if we go back to our timeline again, so we've got a value which is 2723. It's at period 3. We need to take it back to period 0. How many discounts do we have to do? So it's 1 period, 2, 3. So it's 3 periods up until we get to period 0. And that's equal to year 0, which is 2723 divided by 1.05 to the power of 3. And if you were to plug this into your calculators, what you should get is $2352. Okay, so now we're done with discounting our annual costs. Next step would be to look at our annual benefits. So in this case, our annual benefit is what you see over here with the positive sign. So it's the $2,000 that you see. So step 3, that's the annual benefits. Again, we need to use the annuity equation because it's an annual amount. 1 plus I, the power of n, minus 1 divided by I, 1 plus I to the power of n. And now let's go back and have a look at the timeline. So the payment starts at period 3, and using the annuity equation, that's going to give us the discounting amount at period 2. So again, it's going to be broken down into 2 steps of your calculations. First step is to get the present value at year 2 using the annuity equation, and then discount that back to period 0. That will be our second step. So let's do that. Let's first take it back to year 2 using the annuity equation. So at year 2, the first payment, which is at year 3, it's 2,000, 1.05. Now the n, again, the n in this case, you have to count how many payments we have. So we have 1, 2, 3, 4. So we've got 1, 2, 3, 4 payments. And because we have 4 payments, so let me go back to, so because we actually have another payment which is year 2, that's 2,000. So we've got 5 payments for 2,000. So it wasn't 4, it was 5. So n is going to be equal to 1, again 2, 3, 4, 5. So n is going to be equal to 5 minus 0.05, 1.05, 5, and then close the big bracket. What we've got that is equal to 8659. So if you were to plug this into the calculator, you should get 8659. Now remember, Again, I have to delete that, and that's equal to year one. Why is it equal to year one? Well, again, going back to our timeline, the first payment actually starts at year period two, not year period three. And because it starts at year period two, the equation, what it's going to do is it's gonna take you back one period less. So it's going to give you the discounted amount at this period, period one. So our next step would be to take that amount and discount it back to present value zero. And that's what we're going to do now. So to do that, it's going to be step 4, discount previous figure back to year 0. Again, I need to use this equation. 1 plus I n. My f is going to be this amount, so it's present value at year 0, and it's 8659. So what I got from the previous step, 1.05, and now the n in this case, if I go back to my timeline, so I've got this figure now, the discounted figure at year period 0. I need to discount back to year period 1, so that's 1 period less, and hence n is going to be equal to 1 because it's 1 period less. So from year period 1, so if you this year period to that year period, that's equal to 1, and hence why my n is equal to 1 over here. So the answer that I should get, that should be 8247. Okay, so and then step 5, we have, so we considered this, so we considered our annual benefits, we considered our annual costs. This figure that you see over here, we don't have to worry about, and the reason for that is because this is already at year period 0, so there's nothing to worry about. So that initial cost, we leave it as it is. We still have this payment, which is at year period 6, and that's your salvage value, so what you get after you sell your project at the end. So we got $5,000, but we need to discount that back to year period 0. Now, remember, this is not an annual cost. It's just a single benefit that we get at year period 6. So the equation that I need for that is going to be P is equal to F, 1 plus I to the power of N. So the F is going to be the value at the end. So that's your 5,000. So that's 5,000 divided by 1.05. And then the N is going to be the periods that you want to discount. So I'm going to move from 6 to 0, 1, 2, 3, 4, 5, 6. That's 6 jumps that I have to make back in time. And so if I were to plug that in the calculator, what I would get is $3731. Okay, so what do we do now? We need to use NPV, and we need to use our benefit cost ratio in order to determine whether this is feasible or not. So the easiest thing to do now is to create this table. So discounted benefits and discounted costs. So we've got our first benefit is going to be 8247. Where did I get that from? Or if you scroll up, if you guys remember what we did in step 4, that's this figure. What else do I have? I've got 3731. Where did I get that from? Again, if we move up, it's that figure that we got from step 5. That was a benefit, because remember they were associated with positive signs in the timelines. So it was this and it was that. Okay, but this time it was discounted over here in the table. And then what about for the costs? Well, for the costs, I had 2352, and I had, so where did I get the 2352 from? If I go up, that's what we got from step 2. And then finally we had the $10,000, so our initial cost. So what we had at the start over here, that's your initial cost. So I need to sum them up. So summation of all the benefits, the discounted benefits, that's 11,978, and summation of all the costs, That's $12,352. Okay, so for NPV, so for net present value, I need to add the benefits minus the costs. And the way to do that is associate a positive sign with the benefits, associate a negative sign with your costs, and then just add them together. So benefits plus the costs, and the cost has to be in negative. So the cost has to be in negative for you to do the summation, because what we need to get is benefit minus cost. Okay, so what happens is that in this equation, you can use this equation if the cost is actually in negative. Otherwise, if you leave the cost as a positive value, you have to minus it from the benefit. Okay, so just remember that. So in this case, because I already associated a sign, I can use this equation because I already associate the negative sign with my costs. So my benefits, this is 11,978 plus my costs, which is 12352, and the answer that I should get is minus 374. That's less than 0, therefore infeasible. According to NPV. What about BCR? So benefit cost ratio. Remember, for the benefit cost ratio, what I have to do, so I've got to get my benefits divided by costs, compare it to the threshold, which is 1. So in our case, the benefits, if we go up, the benefits were 11,978. Now this time, remember that it's always positive values, so we remove the sign over here, so it's always positive amounts. And that's going to be in a positive amount, that's going to be in a positive amount. So don't report BCR as a negative amount. Remove the negative sign in front of the costs for BCR. Negative is only when we're calculating NPV. So for the BCR, my summation of benefits, that's 11,978. 11,978. The summation of my costs, that's 12,352. 12,352 without the negative sign, and that's equal to 0.97, which is less than 1, therefore infeasible. So as you can see, in both cases, project is infeasible. For NPV, because it's less than 0, and for BCR, because it's less than 1.